Hello, everyone. I'm going to lead an exercise from your homework to find the derivative of a function at a point. So please get ready to follow me. Okay. So please follow me, please. The function we're working with is f of x equals to 1 over root 2x plus 2, and a is 1. So according to this formula, we have f of 1, x is approaching a as a is 1, so everywhere a is replaced by 1. Everywhere a is replaced by 1. X approaching 1. Okay, f of x. I'm going to just to delete some of those things because I did some work before already. So this is f of x, and this is f of 1. F of 1 is when x is substituted by 1. So 2 times 1. And this will be equals to root of 1 over root. Okay, 2 times 1 is 2. 2 plus 2 is 4. And the square root of 4 is 2. So 1 over 2. So we're going to do one step at a time. F of x minus f of 1. So f of x, okay, minus f of 1. So f of x, we put in place f of x minus 1. Okay, so the next step is that. Direct substitution, okay? Replacing f of x by its equal, and f of 1 is 1/2. Okay, so we get to this step. The next step, we need to be very careful, okay? Because even though we have a 2 in the radical and we want to pull it out, if we pull it out, you're going to pull out inside the parentheses, which is going to be 2 times x minus 1. So if you want to separate the variable part with the constant part, and you will get a root of 2. Root of 2. So this is a root of 2, this is a 1/2. Okay? If you want to rationalize it, right, it certainly makes sense to rationalize it. So I am going to rationalize it. Okay, so I'm going to multiply root 2 on top and the bottom. So this part is untouched. Okay, and this way you will get root 2 times root 2 is root 2 squared. Root 2 squared is 2. And the top is a root 2. So this is just the numerator. And next, we're going to just do a little bit, you know what? We just continue to divide by the denominator. Okay, so our next step is going to be numerator divided by the denominator. The numerator, which is this piece, which is that part, right? So there's a big fraction. The numerator is a fraction part, is a fraction form. Denominator, of course, is x minus 1. We got a complex fraction. Of course, the technique to deal with this complex fraction would be to simplify the complex fraction, okay? Before we simplify it, there are a couple of things you can do, and this is optional, right? We can multiply the top by a 2 and multiply the bottom by a 2, okay? So I'm just going to do a separate 2 steps so just to look easier, okay? So I multiply a 2 on top and 2 on the bottom. So this 2 is going to multiply with the 2 over here, right? And multiply the 2 over here. And the 2 in the bottom will multiply with the x minus 1. Okay, so this part is gone. And on this piece, and 2 and 2, there's a multiply 2 divided by 2. So that will be gone. And 2 times half is 1. Okay, you can see it also from here by taking out the half. Okay, you can see this as taking out the half, and then you get that piece. Basically, you factor out the half, right? You factored out the half. This 2 in the denominator is factored out. You get something like this. When you multiply 2 on the top and multiply 2 on the bottom, that's what you got. Okay, so let me show you this one more time, right? So this piece, which is in the numerator, the denominator, of course, is x minus 1. Okay, so when I multiply by a 2 on the top, okay, I'm going to save that piece. So when this piece, I multiply a 2 on the top, multiply 2 on the top, and multiply 2 in the bottom, then we need to exert parentheses. And then this will make 1, and then we'll have 2 times x minus 1, 2 times x minus 1 in the denominator, and the numerator would be just like that in the numerator. And then you can think of continue to reduce the complex fraction. So we're going to multiply the common denominator root of x on top and in the bottom. And by this time, you're going to take this piece to multiply that piece, distributive, right? Distributive. The denominator will be multiplied the denominator. And that's not needed. And we go back to see this part, right? So we'll go back to see this part, and you can see this piece reduced with that piece. So that this part is only just has root 2 left. And 1 times the root of x plus 1 can be omitted. So now we came to this expression. And then what do? By this time, if we look at the limit, we cannot directly substitute because we're going to get denominator equal to 0 when x approaching 1. So we cannot do limit law, right? So we're going to have to continue to rationalize. So let's see where we are here. Rationalization. So we take this piece, right, which is that. We multiply the conjugate of the numerator. And then we get to the next step. Right? We multiply the conjugate over the conjugate, which is times 1. And we get a squared minus b squared, right? Denominator times that denominator. So we got a more complex denominator, but don't try to open it. Don't try to FOIL or expand. Just leave it like that. And the next step, right? We got this. Okay, because root 2 squared is a 2. Root of x plus 1 squared is x plus 1. Okay. And next, I'm going to open up the parentheses here. So the negative sign is going to apply inside. And we got this. Okay, so in the whole time, denominator which we got from here, new denominator times denominator stay the same without any change. Without any change. Okay, so now combining these three, we got a 1 minus x. So denominator stay the same. We got a 1 minus x on the top, x minus 1 in the bottom, knowing that 1 minus x is negative of x minus 1. Okay, you can verify that on a piece of scratch paper, okay, next to you. So which is 1 minus x is equals to negative of x minus 1. Verify that. If you need to pause, pause. Okay, so we got to the next step. We got to the next step. And now x minus 1 and x minus 1 will be reduced. On the next step, we got negative 1 left on the top, x minus 1 disappeared, and we got this piece. Now, if we substitute x by 1, there's not going to be a 0 denominator. So now we can take limit. We are going to take limit. We take limit. Okay, and we've done so much work, right? We have done so much work. Okay, I'm just lining this up, and you can take the opportunity to look back what you have done. Okay, line them up. I like to line them up, so it makes it easier for me to read, and it'll also make it easier for my reader to read. We're taking limit of this piece is a direct substitution. Everywhere x is replaced by 1. Everywhere x replaced by 1. So I got this 2 times root 2, and inside the parentheses, root 2 plus root 2. Root 2 plus root 2 is 2 times root 2. So 2 times 2 is 4. Root 2 times root 2 is 2. 2 times 4 is 8, so it's negative 1/8. Okay, so now that is the derivative of this function. Oops. Okay, the derivative of this function at 1 is equals to negative 1/8. That's all. Thank you for watching. Thank you for following me. And if you'd like to do it again, if you have any questions, please don't hesitate to reach out to me. Thank you for watching.